Hello, welcome to this lecture. This is an introduction to process control. I will briefly see what is process control, what is meant by process control, and what is its requirements, why process control is required. A process is something is what converts feedstock raw material into a useful product. This will involve many equipment, many units like heater, heat exchangers, distillation column, absorption column, separation columns, filtration units, etc. So the process will be carried out in several steps in sequence. The basic idea is a raw material is to be converted into useful product. So this operation consisting of several units, we call it as a chemical plant. This process takes place in a chemical plant, and this chemical plant during its operation has to satisfy many conditions, many requirements from design point of view, from operation point of view, from environmental point of view, from safety point of view, etc., etc. There are several requirements which has to be met with, and we'll see what are the requirements which call for, which are required for the safe operation and useful conversion of the raw material into products. Okay. So that is where this process control comes into picture. And what is process control? So it's an area that deals with control of processes. Control of processes means what do you mean by control of process? So regulation of variables so that your required objective is met with. And what is the objective? The maintaining the variables at desired values. So process control has an objective that the variables, some variables, maybe one variable or more variables, they have to maintain that desired values. So if there are deviations, then if there are deviations in these variables, in a variable whose value you want to maintain at desired values, if there is a deviation in that, then you have to manipulate some other quantities so that the objective is achieved. So this is, in brief, what is process control in a few lines. The objective is to maintain variables at desired values, and if there are deviations, manipulate some other variables, some other quantities. Now, why? Why is this process control required? What are the benefits? Can you not design a process in such a way that there's no process control required? You can design. Theoretically, you can design. For example, if you want to heat a liquid, certain quantity of liquid, say oil, you know the quantity to be heated, you know the inlet temperature, outlet temperature. I want to heat certain quantity of oil from 30 degrees to 70 degrees. You can design a process. You can find out how much the heating medium is required. Say steam. Let's say we use steam. So how much, at what flow rate steam is required to heat this, and what should be the steam temperature? You can design. So once you design this, and if the process takes place as per these design values, then there is no need for any control. What you have designed is, if it is going to be achieved in the real situation, you design how much steam is required, what is the size of the heater required. Then if the process takes place as per this, then there is no need for any control. But practically, it's not possible. There may be so many situations trying to, so many variables or so many conditions trying to upset your calculations. There will be many external disturbances. So this is one of the reasons why you have to go for control. Okay, let us list all the reasons and all the benefits of process control. One is safety. The chemical plant has to operate. When the operation of chemical plant is intended to, as I said, to convert the raw material into useful product, but that has to be carried out in the safest manner. So safety is a matter of prime importance. Safety from the operating variables, for example, pressure. If you decide if there's a reactor, there will be certain pressure beyond which the reactor cannot be operated. So you have designed the reactor to operate, say, at 10 atmospheric pressure. Then you have to ensure that the pressure in the reactor is always less than that, less than the design pressure. In case the pressure exceeds, the vessel may explode. Same thing with respect to temperature also. In some cases, the temperature is a factor that is to be taken into account from the material of construction point of view. The material of the equipment cannot withstand more than certain temperature. In some cases, operating conditions, the process itself will fail if the temperature exceeds. In some cases of reaction, if the temperature exceeds a certain value, there may be unwanted side reactions. So you have to ensure safety in terms of all these variables from the pressure, temperature, maybe even concentration. So you have to ensure that these variables are within the specified limits. That is safety. So for this, you require control system. Then specifications. So this is what I said earlier. You design a process. The process is meant to produce a certain quantity of a chemical at a desired composition or at a desired quality. For example, in the earlier case I told you, you have to heat oil, say 100 kg per hour of oil, quantity is specified, to 80 degrees centigrade. The quality of the outlet is specified, 80 degrees centigrade. So you have to ensure both. Similarly, another chemical. The plant is designed, the aim is to produce, say, 100 tons of a chemical of a specified composition, say 90%. So you have to ensure the quantity 100 tons per day, as well the quality 90%. So this also requires control system. And third one, environmental regulations. There are, when a plant, for a chemical plant, which is going to discharge effluents or pollutants into surroundings or into lakes or rivers, there are government laws, there are government regulations from environmental point of view and pollution point of view. So the operation of the plant should comply with these regulations. For example, if discharging an effluent, liquid effluent into a river, the regulations would have specified the limit of the components, the pollutant components in that. Similarly, stack gases may consist of noxious gases, CO, SO2, etc., etc. So the regulations mandate that these components should have a limit. So to ensure these limits, to ensure that these regulations are complied with, we need process control. And fourth one, the operational constraints. Many of the equipment used in chemical plant, they have these constraints. Constraint means we cannot operate them in the way, they may not have full freedom to operate in the desired way. For example, if you have a tank, so there will be a constraint that the liquid level in the tank should not fall below a particular level. So we do not have freedom that the liquid can occupy any height in the tank. Similarly, if there is a reactor, there will be a constraint there may be a constraint that the temperature should not exceed this level. So for reactor, temperature may play in more than one way, may play a role in more than one way. One is the material of construction. So the material of construction decides what should be the maximum temperature. Apart from this, the operating conditions of the reactor also may specify a condition with respect to temperature. For example, if the temperature exceeds a particular value, the reactor material may be able to stand, but the reaction will fail. There may be unwanted side reactions. The product will get contaminated. The reaction will not take place to our expectation. In some cases, if the temperature crosses a limit, the reactor may become unstable. The temperature is called unstable reactor. The reactor may become unstable. So this is one example of operational constraints. So we have a limit in many cases, limit of temperature in reactor operation. Similarly, if you take a furnace where fuel is burnt, there may be restriction on air-fuel ratio. So you'll specify, I want this air-fuel ratio. I don't want more than this or less than this. Similarly, when two streams are mixed in a tank or vessel, there may be a constraint that one stream the ratio should not become more than a particular value. So these are all operational constraints which have to be taken care of by having a proper control system. Well, I taken care of safety. The product specifications are ensured. Environmental regulations are complied with. The control system can take care of that. And the operational constraints, if there are whatever operational constraints are there, that also can be met with by having a proper control system. Then, in addition to these, comes the more important factor from cost of production point of view. Of course, basically any operation, any plant should operate in such a way that the profit is maximized. So the economics of the process, economics of the operating conditions are to be taken into account. For example, the raw material, availability of raw material. There may be many choices for raw materials. So which raw material is available in more quantities, ease of availability of raw materials, the demand for products, and the operating conditions also should be taken into account. For example, if you take any one operating parameter, so one operating parameter, for example, temperature. This operating parameter from this may be advantageous in one way. For example, in some cases, it will be advantageous to have a high temperature from one point of view. high temperature may be advantageous in one way, in one sense. But for the same process, the same high temperature may also become disadvantageous in another aspect. So temperature will acting in both ways. In some aspect, it is advantageous. In some aspects, it is disadvantageous. For example, it may, in one case, the high temperature may increase the quantity of production, but at the same time, it may lower the quality. I'm just giving an example. It's not that always should happen. So what I'm trying to say is a parameter, a variable can, in many cases, act in two different or two opposite ways as far as the operating condition or maximizing the profit is concerned. So you have to select and carry out that particular operating condition which maximizes the profit. So for this, you have to take into account, take into consideration the economics. So based on the economical, with this economical objective, we should be able to arrive at operating conditions and maintain that operating conditions with the aim of maximizing profit. So here also the role of control system, the control system is expected to play a good role, important role. So these aspects, safety, specifications of the products, both in terms of quantity and quality, the environmental regulations, the operating constraints, and the economical conditions, or the reasons why process control system is called for in a chemical plant. Well, okay. Now, having understood the role of control system and why it is required and what are these benefits, these why as well as explains the benefits also, right? Because if the environmental regulations are not met with, you will not have license to operate your plant. If the specifications are met with the control system, but still if there is no safety, you cannot operate the plant. So these 5 points tell you why control system is called for as well as its benefits. Now, having seen this, what should a control system, what is a control system expected to satisfy? What are the satisfactory requirements of a control system? You should do all these things, right? We are called for, the process control system is called for these aims to carry out to achieve these aims. But what are the requirements of the control system? What should it do? The requirements of control system. So number one, it should, so we'll see the overall requirements. We will go to the deep depth of these points as we go into the subject, chapter by chapter. So the first requirement is it should suppress the influence of external disturbances. So let me go back to the example of heater, where I said a known quantity of oil, say 100 kg per hour, is heated from 30 degrees to 70 degrees. Heating 100 kg of oil from 30 degrees to 70 degrees is the objective. So you design a process, you find a heater of specified size, your design specifies how much steam is required at what temperature. Well, I design this, operate this process. So this process will give me the required objective, that is 100 kg per hour at 70 degrees output, as long as the designed variables are constant. Nothing happens to these variables. For example, what are design variables? Input temperature 30 degrees. The steam temperature is specified, maybe 100 degrees centigrade, or steam pressure is specified 2 atmosphere. Steam quantity is specified. As long as these things are constant, you will get the required output. Is it not? But suppose if there is a variation, because of external disturbances. Suddenly the input temperature, inlet temperature of the oil itself goes below 30 degrees. It is not 30 degrees as you were designed for. It is not 30 degrees as you had expected or as you have specified. Suddenly it becomes, someday it becomes, or some particular hour it becomes 20 degrees. Similarly, the steam pressure you are specified as 5 atmosphere. The steam pressure suddenly drops, steam temperature drops, or the steam quantity, steam which is used to heat the oil, the quantity drops because of some problem elsewhere. So you get, that means you are getting into the process is disturbed by external factors. The steam flow rate is reduced or inlet temperature is reduced, external disturbances. So if these external disturbances are not corrected, then you will not get your required objective of the oil output being 70 degrees, right? So if these external disturbances are not corrected for or not rectified, you are not going to get your objective. So the control system, when you put a control system, that should be able to suppress the influence of external disturbances. Means the control system should be able to compensate, correct or compensate the effect of these disturbances, which are going to, these disturbances are going to decrease the outlet temperature of the liquid. These disturbances are going to have an adverse effect on our objective. So the control system should be able to compensate these external disturbances which has happened and bring back the output variable, the liquid outlet temperature, to our objective value, to desired value of 70 degrees, right? So the control system should be able to suppress the influence of external disturbances. Next, ensure the stability of a chemical process. Control system, when it does the first point, when it suppresses the influence of external disturbance and try to bring back the variable of a desired variable to desired value, what may happen is sometimes it does the opposite effect also. Sometimes, in some cases, in some type of control system, if it is not properly designed, instead of the outlet temperature coming to 70 degrees, it may grow in one particular direction. It may keep on increasing from say 70 to 80, 80, 90, 90 without any control, or it may keep on decreasing from 70 to 60, 50, 40, etc. So contrary to the belief, you may think right now that control system, once you put a control system, we are going to get back the desired value of the output variable. In this case, what the example, I'm sticking to the example that the output temperature of the liquid. But even though this is a small example, this may not happen here, but in many cases, many other cases, in some type of control system, it is possible that if control system is not properly designed, it may have the opposite effect of making the process unstable. So control system is basically expected to what? If there is a variation, if there's any external differences, the control system should suppress them, should compensate them, and bring back a stable value in the output, that is stable value in the outlet temperature of the liquid. But it is possible that in some cases, the control system not properly designed, that if not properly designed, it may make the system unstable also. It may become unstable. Unstable means the output variable not coming to a fixed value as you expected. So the control system requirement of the control system is it must ensure the stability of a chemical process. So it should not only suppress the influence of external disturbances, but it should ensure the stability of chemical process. The stability of control system is a major topic you're studying in when you go to control system analysis. So that is why it is mentioned here. Important requirement of control system after the first one. First one is basic. You should suppress the influence of external disturbances. You should compensate the external disturbances. But while doing so, it must ensure that the chemical process is stable. Right. The third one is what? This is about the economics. You should take into account the economical objective. You should optimize the performance of a chemical process. Chemical process, there are so many variables. As I said, one variable may act in both ways. It may be advantageous or it may bring unnecessary problems. It may become disadvantageous in another way. Some parameter will be economical, some other parameter will not be economical in one way, but it may be useful in some other way. So we cannot do away with a particular variable and its particular value in all cases blindly. So you should optimize selecting the parameters. And also, as I said earlier, the economics of the process, the economics of operation is also should also be taken into account. And the operating conditions, the economics, all these things should be taken into account, and the control system should be able to optimize the performance of a chemical process. Optimize means basically in online, maximize the profit. So should be able to optimize the performance of a chemical process. So these are the requirements of control system. We've seen what is control, why control is required, and what are the benefits, and what are the requirements of control system. These are all just in overall. We have taken a broad view. So if you go into each topic, like first one, suppress the influence of external disturbances, how and what are its effects? When you try to suppress the influence of external disturbances, what happens? Will you always, are you always, are you going to be always successful, smoothly? Is it going to be a smooth affair? When you do this, are you going to get a stable chemical process? And what do you do to ensure the stability of a chemical process? So each one is going to be a topic in great detail. So which we'll study in the coming chapters. So each one will require, we'll be dealing with each point, whether it is suppressing the influence of external disturbances or ensuring the stability of a chemical process. We'll be dwelling, we'll be taking, we'll be talking in detail about each of these topics in the when we study the subjects in detail. Because optimization may not be part of, we will not be studying much in our course. Will be, but even though but it is still a requirement of control system. When you design a control system, you specify the variables for optimization. The control system will take into account and will perform the optimization. But what are the parameters? How do you select those optimization parameters? So that will be left to the respective process details. Okay. So this may not be a, how do you choose the optimized parameters requires all other topics. If it is a reaction engineering, if it's a reactor, then you have to know reactor conditions, reaction engineering. Okay. So like that, if that depends on, that involves the study of the respective subjects. But the first two will be part of our study in detail in process control. Well, so that is about brief introduction of what is process control, why it is required, and what are the requirements of control system. We'll see you. I'll see you in the next lectures with more information on process control.